Okay. Yeah, so I was saying focus on questions to do with sets, okay? Those binary operations, complex numbers, those kind of questions. Then we'll also solve some questions on functions, cubic functions, quadratic functions, okay? Then we'll look at equations. I believe everyone is comfortable with equations. Then we are also going to solve questions on inequalities. Okay, so that's what we'll do this morning, and we'll continue as per schedule until you write your exams. Yeah. So I shared the schedule with you guys. You can also use it as a study guide, making sure that you cover all the important topics for your exams. Okay, so here on top I have different papers. Okay, so I have this one is for last year math 1100. This is for math. No, this one is math 1100. The other one is 1120. Then this one is for SAP for last year math 1100. SAP for 1120. Then these are the 2022 papers. So we'll solve questions from these 6 past papers based on sets, functions, equations, and inequalities. Okay, so this one I already solved questions from here. Even this one I already solved. So I'll start with this one. What's up? 1100. Okay. So we are dealing with the questions that involve sets. Okay, so solve some questions here, and then we move to the other paper. We solve some questions just like that. Okay. So let's begin. All right. So here, question 1. You can see this question here is saying sets A and B and C all intersect, and E is the universal set. Given that C is a subset of A, shade on the Venn diagram the set described by this here that I've given. Okay. Okay. Make this is okay. So we are shading this. Okay, we're shading this set based on the information that you've been given here on top. So they are saying A, B, and C all intersect, and then E is a universal set. Then given that C is a proper subset of A, okay? This symbol here with a C and a line down there, it means a proper subset of A, meaning this set C is equal to the set A, okay? So whatever is in set C is also present in set what? A, okay? So set C and set A, they are equal based on this kind of information that they have given us now. Now they want us to shade this, okay? So let me go to my board. Okay, so there they say the C intersection A minus B complement. Okay, so intersection, open brackets, A minus B complement. Okay, taking note that C, okay, what was there? Okay, C is a proper subset of A. Okay, taking note that C is a proper subset of A, and all the sets A, intersection B, okay, intersection C, they all intersect, okay, according to this information here. Okay, so how do we shade this given set here? Okay, so the first step is always to simplify whatever set that you've been given. Okay, so from the laws of set, we know that A minus B is the same as A intersection B complement. Okay, so this A minus B is the same as that. Okay, then again, this is exposed to a complement outside there. Okay, meaning here you have C intersection. Okay, then this complement multiplied by that A. Okay, multiplied by that A to just be A complement. Then this complement multiplied by the intersection there it will be union. Then this complement multiplied by B complement there to just be B, okay? Because two complements, they cancel each other. So from this set, we now have that set, okay? So can we simplify this set further? Can you simplify it further? Hello, can you simplify it further?
No, sir.
Okay, yeah. So I think this one, we are good to go. So let us shade that now, considering what we've been taught here, okay? So they are saying C is a subset of A, okay? And then A and B and C, they all intersect. So how do we draw that? Okay, so first you draw your universal set like that. Then you say, this is my universal set, okay? Then let's draw set A there, okay? So this is set A. And then let me label it. So this is set A. And remember that C is a proper subset of this set A, okay? Meaning set A is the same as set C. So how do we show it? Okay, so you can just draw another circle just inside there to indicate C, okay? So let me use a different color here. So for C, we'll draw with orange and we'll indicate like that, okay, like that, okay. So that is our C there inside here, okay? Then we've shown this property here where they're saying C is a proper subset of A, meaning all the elements in C, they're also in A. All the elements in A, they're also in C, okay? Then let's now add the B, okay? Because they said all these sets intersect. So meaning the B will just come there, okay? Let me draw it in red. Let me draw the B in red. Okay, so the B will come there like that. Okay, this is our B. Okay, then after drawing this, then we can now come to this guy here and use it to shade. Okay, so I'll shade first C. Okay, C, let me shade with its color orange. I don't know if that's yellow. Okay, so set C is this one. I've shaded it. Okay, then this set C is intersecting with A complement union B. Okay, A complement union B. Okay, so what is A complement? Okay, what is A complement? It means you shade whatever is outside the set A. Okay, so whatever is outside the set A, we shade it like that, like that. Okay, like that. Shade. Okay, that's our A complement. We've shaded. Then this A complement, we are unionizing it with what? With B, okay? So meaning we come here and we shade our B. So B, we used red. So we are going to shade with red. So B, let's shade there. There. Okay, so we've shaded all what we have here with different colors, okay? So let us first get this, okay? Then we intersect it with C, okay? So where is our A complement union B, okay? So wherever you are seeing blue lines and red lines, okay? Blue lines, red lines, that is where the A complement union B is, okay? So meaning all this part here, including that part there. Okay, then this the blue and red should intersect with the yellow for the C. Okay, so where is this yellow coming in contact with either the blue or the red? Okay, so you can see that it's just this part here, this part here, this part here. I don't know if you can see this part there, just that part there. It's the one that is intersecting this. Okay, so you only shade that part there. Okay, so now I was using this to explain, but let me draw it here now so that I show you the part. So we had set C, we had set A, and then we had our set B there. Okay, so the part that we've shaded there, okay, the part that we've shaded there is just this part here. Okay, so this is our C, this is our A, and then this is our B. Okay, so I don't know if there are any questions on this. Hello, should I proceed?
Yes, sir. Proceed.
Okay, so let's go to the next question. Okay, so let's look for another question. Okay, so it said we've solved some. Let us solve some more sides there. Okay, so here, this question they're saying, given this, express it in the form P plus Q root of 5. Okay, P plus Q root of 5. So what are we going to do there? Okay, so in this question, they're simply telling us to rationalize this denominator. Okay, to express this in this form, then we have to rationalize the denominator here. And how do we rationalize that the denominator? We simply multiply the denominator by its conjugate, and then again on top there, we multiply by the conjugate of the denominator. Okay, so we have 2, 3 plus root of 5, then 3 minus root of 5 down there. Okay, so here we have 2, 3, okay, plus root of 5 on top there. Then down there, what do we have? We have 3 minus root of 5. Okay, so how do we express it in that form? We simply rationalize the denominator. How do you rationalize the denominator? You multiply by the conjugate. Okay, so what is the conjugate of this? You just simply write the same thing, and then you change the sign in between there. Okay, so there you have that. On top again, you have that. Okay, simple as that. Then you multiply. Okay, so on top there, what are we going to have? We're going to have 2, 3 plus root of 5, then again 3 plus the root of 5 there. Okay, then down there, we're going to multiply the conjugates. Okay, so whenever you're multiplying two conjugates, you just square the first number, then minus, you square the second number. Meaning, if you multiply this there, what are we going to get? We said square the first number, then minus, then square the second number. Okay, so this is a shortcut, no need for you to expand. So 3 squared is just 9. Then root of 5 squared is just root of 5, so minus 5. Okay, meaning down here, we're just going to have power 4 like that. Okay, so let us now multiply whatever is on top there. So 2, okay, then we multiply what is in the brackets. So 3 by 3 is just 9. 3 by root of 5, it's 3 root of 5. Okay, root of 5 by 3 is still 3 root of 5. And then root of 5 by root of 5 is just 5. Okay, so we have that on top. And then down here we still have our 4. Okay, so 2. Then on top there, we put like terms together. So 9 plus the 5, it is 14. Okay, then this 3 root of 5, 3 root of 5, just be what? 6, eh? Okay, yeah, 6 root of 5, then over 4. Okay, so from there now we multiply by the 2, or we simply say 2 into there 1, then 2 into there 2. Okay, so you have your 14 over 2 plus your 6 root of 5 over 2 there. Okay, then you divide there, you have your 7 plus, and there you have your 3 root of 5. Okay, as simple as that. Okay, so that's how you express that in that form. Okay, simply rationalizing the denominator. Okay. Any questions, guys?
No.
Okay, so let's go to the next. Which one can we solve here? Okay, I found this question intimidating. It troubles a lot of people, especially if the ones that are repeating, they are not next to the decimal place. Okay, so how do you handle that? So yeah, 0.023. Okay. Yeah. Okay, so I have a 0.023. What number is there? Okay, that's the number. Then you have a bar there. Okay, so if the bar was starting from here, okay, if the bar was starting from here, mostly people don't have a problem with that. Okay, but if the bar is inside there, then people tend to have problems. Okay, so we're expressing this number in the form A over B. Okay, and we know that any number that is expressed in the form A over B, we know that that number is a what? Is a rational number, guys. Okay, it can be expressed in form A over B. So how do you go about such equation? Okay, so whenever you are given such a number that has recurring decimal numbers, okay, and they tell you to express it in this form, always make sure that after the decimal point, okay, that after this decimal point here, immediate after the decimal point, you have numbers that are repeating here. Okay, so in this case, we don't have numbers that are repeating here because this 0 and 2 are not repeating. The one that are repeating is 2 and 3. So what do? You just have to move this point, okay, to the point where you only have repeating numbers after the decimal place. Okay, so you move this point 1, 2, okay, 2 times. Okay, so what does it mean when you move this point 2 times? It means you multiplied this number by 100, okay, because 100 has 2 zeros, so it has moved 1, 2, okay. It was 1,000, it would have moved 1, 2, 3, okay, just like that. If it was 10 to move just one place, okay. So when solving this, the first step is to let x be equals to the number that you have given, the number that you are given in the equation as it is, okay. Then the next thing is to check, are these numbers after the decimal point repeating? If they are not, you make this number to have only the repeating numbers after the decimal point. So how did we move this to there? Okay, we said we multiplied it by 100. Okay, so that x we multiplied by 100, and then what are we going to get there? We are going to get 2.23 bar there. Okay, so you can see here that we've moved this point to a point where after the decimal place, we only have numbers that are repeating. Okay, we only have numbers that are repeating. Then after that, okay, you have to move this point again. You have to move to a point where you have another set of repeating numbers. Okay, because this number is repeating, meaning after these two, you have 2, 3 again, you have 2, 3 again, you have 2, 3 again, just like that until forever. Okay, so you move this point to a point where you have these repeating numbers beginning again. So we move 1, 2. Okay, so this point should come there. Okay, so what have we done for us to move 1, 2? Means we've multiplied by 100 again. Okay, so this 100 multiplied by 100, what do you get? 100 multiplied by 100, you get a 10,000. Eh? Okay, so it will be 10,000 x is equals to, okay, this point to move from here 1, 2, meaning you have your 2, 23 there, point, okay, 2, 3, 2, 2, 3, you can write as many as you want there, okay. So why are we doing all this? Okay, why are we doing all this? The point is that the number that you get here and the number that you get here, when you subtract them, the numbers after the decimal places should give you 0. Okay, so that's the point. Okay, that's why we made sure here after the decimal point we have the ones that are repeating. Even here after the decimal point you have the ones that are repeating. Okay, so what? The next step is to subtract these two. Okay, so you say 10,000 x minus 100x. Okay, so someone to do it on a calculator, what do you get? 10,000 minus 100. Okay, then here you put the number for 10,000, which is this. Okay. Then down here, you put the number 400. Okay. So 400 is 2 point. Make sure the decimal places are in the same line. Okay. Then you say minus there. Okay. So when you subtract this, you can see that after the decimal places, we only get 0. Okay. So this should be okay. But when you subtract the two numbers that you've made, you should get a 0. 0, 0, 0. Okay. If you find a number here, then just know that we went wrong somewhere. Okay. So you have to start again. So here, when you subtract, you have 1 there, there have 2, and then there have 2 again. Okay. Then here, when you subtract these guys, what do you get? 10,000 minus 100. I don't know.
9,900.
Okay. So someone is saying 9,900. Okay. 9,000-ish, whatever am I writing? Okay, so 9,900. Okay, very good. So this is our x. Okay, then after that, you divide both numbers by the same 9,900. Even there, you do like a 9,900 like that. Meaning our x would just be equals to, okay, 1 over the 9,900, okay, which is equals to, so if there are numbers that can go into this number and that number that's leaving a remainder, you make sure that you reduce it, okay? If there are no numbers, you just leave it like that, okay? So here I can see that A3 can go into this number, okay? So 3 into 22 is just 7. No, 3 can go into this number. Can it, guys? No, it can't. Okay. 221 divided by 3. No, it can't. So 3 can't go there. Okay, what about 9? 9 can't go there. Okay, so if you find that there's no number that can go into that one and that one, then you just end there. Okay, so this will be your answer. It means you've expressed that recurring decimal in the form A over B, which is what? This here, and we call it as a rational number. Okay, any questions, guys? Okay, no question. I'll move to the next. Okay, I want to do some, okay, let me do binary, then we can solve some functions now. Okay, so let us look at this question here, number 2A. They're saying the binary operation star on real numbers is defined as A multiplied by B is equals to A plus B plus AB, okay? A plus B plus AB, okay? Then is the binary, is star a binary operation on real numbers, okay? So they're asking us to prove is that star is a binary operation. Then number 2, they're saying evaluate. Then number 3, they're saying is that star commutative on R, okay? So those are the 3 questions that we are going to deal with, okay? So let me go to my board. Okay. Okay, so what do we have there? A star B. Okay, A star B is equals to A plus B plus AB. Okay, so this is the binary operation. And our first question, they are saying, show that this star is a binary operation. Okay, so the question comes back to us. Okay, and it requires us to define or to know what a binary operation is. Okay, so what is a binary operation? Okay, what is a binary operation? Okay, so they are saying we prove if it's a binary operation on a set of real numbers. Okay, so if this star is a binary operation, then it means if this star is a binary operation on real numbers here, okay, then it means when we get any two real numbers here, okay, and apply this operation, the answer, okay, should be a real number as well, okay? So when we get two numbers that are real numbers, apply this operation, the answer that we should find should be a real number as well, okay? So if that is satisfied, then we conclude that that operation there is a binary operation. If it is not satisfied, then we conclude that it's not a binary operation, okay? So if A, okay, and B are real numbers, okay, then A star B, okay, should also be a real number, okay, should be a real number, okay. So if we find that A and B are real numbers, then after applying this operation, we also find that the answer to this A star B is a real number, then that star there becomes a binary operation. So you can test any two numbers that are real numbers here. You can test them in this formula here. Okay, so let's say, for example, I get A as my -1, and then B I get as 2. Okay, so let's test these two numbers. Okay, so this is our equation here. Okay, so A star B is equals to that. So meaning that we have -1 star 2 is equals to, it was saying A plus B, so we say in place of A you put B, 1 -1 I mean, in place of B you put 2, then what was there? It was plus AB, okay, so plus, I don't know why I put B here, I'm supposed to put 2, okay, plus 2 multiplied by -1, okay, okay, so here you're supposed to put 2 like that, okay. Then let's find the answer, okay? So what is the -1 plus 2? -1 plus 2 is just 1, okay? Then plus, what do you get when you multiply 2 multiplied by 1? You just get -2, okay? Then after that, what do you get? You get a -1, okay? So you can see that -1 here is a real number, okay? 2 here is a real number, okay? Then we applied this operation that states this, okay? After applying, the answer that we got is also what? A real number, okay? So as long as this is satisfied, then you conclude that this star is a binary operation, okay? So you write in capital it as a binary operation, okay? So you can finish the word there. So it is a binary operation, okay? So in the case where you get some two real numbers here, you apply them there, then you get a number here that is not a real number, okay? For example, you get a complex number, okay? Then that would mean that this operation here would not be a binary operation. But in this case, when you get any two real numbers, you apply them to here, you will still be finding a real number. So this star here is a binary operation. And this was our question 1. Then we go to question 2. Question 2 says what? Says we evaluate this, okay, using this rule here, okay. So I have 2 star -1, okay, in brackets, then star -3, okay, 2 star -1 there, then star -3, okay. So what rule are we using to find this? We're using the same rule, A star B that we've been given in the equation is equals to A plus B, okay, plus AB. So we are using this to evaluate this. So what do you do here? You start with what is in the brackets. So always you start with what is in the brackets, okay? So you get these two numbers here, you apply this operation here, okay? So you are going to say, we're going to say that 2 star -1, okay, star 3 there, then these are in the brackets, so is equals to, okay, so we are applying the operation on these two, So we are following that. So wherever there's A, we put 2. Wherever there's a B, we put -1. Okay. Then that plus, we multiply our A and our -1 there. Okay. So whatever we get the answer here, we apply the operation again with 3, the one that is outside. Okay. So what is the answer inside there? This will be 2 minus 1. It will just be 1. Then plus, okay, 2 multiplied by -1 to be -2 there, okay? So plus multiplied by negative, you get a negative. So this will be 1 minus 2 there, okay? So 1 minus 2 is just a -1. So what all this is just giving us a -1. Then this -1, we apply operation with 3, okay? So again, we follow this rule here, okay? Don't discard this rule. That's what we are following. And what does that rule state? It states you write that A plus the B now there is 3, okay? Plus, then you have your A, which is -1 in this case, multiplied by the 3, which is the B, okay? So is equals to 3 plus -1 is just 2. Then there you have your -3 like that, okay? So meaning our answer here is just -1, okay? So from whatever we had here, this complex thing here, we've simplified it, and our final answer is this, okay? So if you have any question, feel free to ask. Then I'll go to the third one, where they're saying, prove that this operation here is commutative, okay? Prove that that operation is commutative. So when you talk about commutativity, okay, it means that the answer that you get when you do A star B should be equals to the answer that you get when you do B star A, okay? So this should be equals to that, then this binary operation here will be commutative, okay? So it means this side, what do we have? We have A plus B plus A multiplied by B. And then the other side, what do we have? Following the same rule, we have B plus A plus A multiplied by, B multiplied by A, okay? So is this different, guys? According to your judgment, even without testing with numbers, is this different? What I've written here, this side and that side, are they different? No. Guys. Okay, so I can see no difference there. Okay, someone said no in the comment section. So these are not different because this is A plus B plus A multiplied by B. We know that multiplication is commutative. So A multiplied by B, B multiplied by A is just the same. In addition, it's just the same there. So whatever we have on the left-hand side there is the same with what we have in on the right-hand side. Okay. Okay. Okay, meaning here the left-hand side, what I was saying is equals to the right-hand side. Okay, and since this condition is satisfied, you conclude that this star here is indeed commutative. Okay, this is commutative there. So you can finish the word there. Okay. Okay, I'll send the paper in the book, don't worry. Let's look at other concepts, okay? So we solved some questions from the SAP, okay, for last year on sets, on what, okay? So let's solve a bit of function here, then we can move to another paper. Okay, so let's solve that function. Okay. So this one says let f be equals to let f be equals to 2x plus 4, and then g we have 1 over 1 minus x over 3. Okay. So we have our f is equals to, okay, what did you say? We said 2x 2, and then our g we had 1 minus x over 3. Okay, so I'm sure that is correct. Okay, this is plus here, not minus. Okay, so the first question they are saying find the inverse of g. Okay, find the inverse of g. So here is the plus. So find the inverse of g. So how do we find the inverse of g? Okay, so this is a very simple question. We just say that we let our g of x, okay, be equals to y. Okay, and then in that equation there, however there's g of x here, we replace with the y. So to be y is equals to 1 minus x over 3. Okay, so over 1, then we say cross multiply there. Okay, so when you cross multiply, you get 3y is equals to 1 minus x. Okay, so what we want to do here is make x the subject of the formula. So how do we make x the subject of the formula? We take whatever is not x to the other side, so that here just remain with x. Okay, so meaning here we have x can come this side, it will be a positive x here is equals to, and this side you have your 1 and your minus 3y there. Okay, so after this is the inverse. Okay, because we made ax the subject of a formula there. So now we can say that your x is equals to g inverse, okay, of x. Okay, and then your y is equals to x. Okay, and then just replace this into this equation. Okay, so wherever there's x, you put g of inverse of x. Then wherever there's y, you put x. Okay, so this one will be the g inverse of x will be equals to 1 minus 3. Wherever there's y, you put x. Okay, so this here is our inverse. Okay, that's there, our inverse. Very simple. Then what's the following question? Saying find the composite function of f of g of inverse. Okay, f of g of inverse. So it meaning we are getting this equation for g and we are putting it into the equation for what? For f. Okay, so we are inserting g into f. So they are saying f of g inverse, okay, of x. Meaning we are getting this inverse of g and putting it into that function of f. Okay, so equals to, so you write the function of f here. So the function of f plus 2x plus 4. Okay, then is equals to 2. Okay, what is x? Wherever this x, we insert, okay, we insert this g. Okay, so what is the inverse of g here? Okay, so you can see that the inverse of g is 1 minus 3x plus 4. Okay, like that. Then we can solve now. So 2, then 1 plus 4 to just be 5, then minus 3x there. Okay, so there, what do you get? You get your 10 minus 6x. Okay, so this is your f of g inverse of x. Okay, so this is the equation there. Then we move to the next one. They're saying solve the equation f of g inverse of x is equals to 2. Okay, so meaning my screen has gone. Okay. Okay. Let me do this. Stop share and share my screen again. Okay, so that I don't lose it. Okay, so from here now, we're just finding So f of g of 1 of 2, okay? Not of 2, what am I doing? We're equating whatever we have of f of g in this, we're equating it to 2. So we're saying 10 minus 5x, okay, is equals to 2. So we are solving this equation there. So how do you solve this? Like terms together, okay? So minus 5 will remain there, is equals to 2 minus 10, okay? So it means we have minus 5x is equals to 2 minus 10 to just be minus 8. Okay, then divide by minus 5 here. Even there, divide by minus 5. So it means our x there just be equals to 8 over 5. Okay, so there is our correct answer, like that. Okay, so we are done with that question. Someone is writing something in the comment. It's minus 6. Okay. Where is it minus 6? Just a minute. Okay. Oh, here is minus 6. Okay, I get. Why did I see that? Okay, but you've gotten the concept of how to solve. Okay. I might have used 5 here, but you've gotten the concept of how to solve it. Okay. So you can just put a 6 there, 6 there, 6 there, even there, divide by 6, 6, 6. It means here this one will be reduced now. Because of 2, that can go into 8 and 6. So there to be 4, and then down there to be a 3, like that. Okay. Yeah, I think that's better. So let's go to another question. Okay. What is happening to this screen? Okay. Okay, so we've solved some functions from here. Then we can solve from method event 20 now. Okay, so let's solve some functions again from this paper. I know most of you are comfortable with these things. Okay. Let's solve this nice question here. Okay, this is a piecewise function. Some people get confused on this. Okay, so we're solving this question here that I've circled. Okay, so what is the question saying? It's saying given that g of t, okay, is equals to 3 different equations here. Okay, you can see that here it does this question with its range there. Then there's again this equation, there's again this equation, each of these equations with their own ranges there. Okay, so you can see that this g of t, okay, when it's less than or greater than 4, okay, when it's less than or greater than 4 here, you use this as your equation, okay? But when this g of t is between, okay, it's between 15 and minus 4, then you use this equation here. But if it's greater than 15, okay, you use again that equation, okay? So you can see that each of these functions here has a different range, meaning you can only use it in the range that it is supported by. Okay, so now let's evaluate the following down here. Okay, let's evaluate these questions. So they're saying evaluate each of the following. Then they have given you a g of minus 6. Okay, g of minus 6. So that minus 6 there is representing the t. Okay, so if you got what I was explaining, okay, so if we're given g of 6, then which of these equations here are we going to use? Anyone?
The
first one?
Yes, sir.
Okay, yeah, so that is true. Why? Because the t there is minus 6, and we can see that this minus 6 here is less than what? Minus 4 there. Minus 6 is less than minus 4. So meaning for this one here, the equation that we're going to use is this one on top here, okay? Then for this G of 1, which equation are we going to use? Okay, this one we can see that it's in this range from -4 to 15. The one is somewhere in between there. So meaning for this one, we are going to use the equation, the 10 there, okay? Then this one is G of 21, meaning which equation are we going to use? We're going to use the third one, okay? We can say that T is greater than 15, 21 is greater than 15, okay? So, okay, so it actually from right here. So if you say G of -6, okay, is equals to, you're going to use this equation here on top. So it will be 3, then wherever there's T, you put it squared minus 4, I mean plus 4 there, okay? So what are we going to get here? To be 3 multiplied by, what is -6 squared? Just 36, eh? Okay, then plus 4. So meaning 3 multiplied by 36. Okay. So what is 3 multiplied by 36? Okay. So 3 multiplied by 36 is somewhere like 108. Then to this 108, you add your 4. Okay. So meaning your answer here will just be a 112 like that. Okay. So this is your answer here. Then on this G of 1, it means we are using this equation here. Okay. So GT there is just equals to 10. Okay. So when you have your G of 1 there, it's just the same as 10. Okay. 10. Whenever you have a number that is between -4 and 15, your answer will always be 10. Doesn't matter what you input here. G of 1, G of 2, G of what, as long as it's in between these two numbers, the answer will always be what? 10. Okay, so here you are done. Then you go on G of 21. Okay, so G of 21, what equation are we going to use? We're going to use this last equation here. So 1 minus 60. Okay, and now that T is 21. Okay, that T is 21. Okay, so that 21, you multiply it by 6. Okay, it will be 21 by 6. To be something like 120, 126. 126. Okay, so 1 minus 126. What are you going to get? You're going to get minus 125. Okay, so I hope that piecewise function there is clear. Okay, I hope it's very clear because it tends to confuse some people there. Okay, so let's move on. Let's solve another question. Okay. Okay, so let's solve a bit challenging question now because that one was straightforward. Eh? Okay, so we're still on functions. Okay, I hope you've got that one. Okay, so now let's solve these equations here. Okay, they are all functions here, so let's try to solve them. Okay. So I'm solving this question 3. Okay, the whole lot of it because this is this function. Okay, then after this, we'll look at those cubic functions. Okay, the ones we are debating about in the group. Okay, so let's solve this. Okay, so they're saying let f be the function defined by f of x is equals to 9 over x squared minus 9. Okay. Question 1, they are saying state the domain and the range of f. Okay. state the domain and the range of f. So how do you state the domain? How do you state the range? Okay, so this question is kind of confusing sometimes. So what you have to know is that the domain, when they say the domain, okay, when they say the domain, they are just simply asking you to give them the x values that are valid in that equation. Okay, that will make that equation valid. When you substitute that x value there, it will give you an answer. That's simply what they mean by the domain. Okay, then the range, it's those y values that you're going to get after you substitute the valid domain. Okay, so domain x values, range y values. Okay, so there we have our f of x. Okay, let me use it. Much more comfortable with it. Okay, so we have f of x there is equals to, they've said what here? Just go on 9 over, okay. Dang, let's go on again. Why does this keep on happening? Okay. All right. Okay, so you have f of x is equals to 9 over x squared minus 9. Okay, then they're saying find the domain, find the range. Okay, so I said domain, x values, range, always know that we're talking about what? Y values. Okay, so let's find the domain. How do you find the domain? You simply equate the denominator to 0. Okay, equate the denominator to 0 and find the x value. So we're going to say x squared minus 9 is equals to 0. Okay, so x squared is equals to 9. So what do you get when you do a square root there, then a square root there? Okay, so x squared, I mean x now, since this square will go, is equals to plus or minus 3. Okay, plus or minus 3. So what does it mean? What does this mean? Okay, it means the x value that you put here should never be 3 or minus 3. Okay, should never be 3 or minus 3. Okay, so this x should never be equals to positive 3 or minus 3. Okay, so it means in our domain, we are going to exclude positive 3, and again, we're going to exclude the minus 3. Okay, so you say domain, okay, is a set of all x values such that x should not be equals to minus or plus 3 there. Okay, so x is a member of real numbers. I haven't written it properly here. Okay, so let me write it again. Saying domain is equals to x, okay, is such that x is a member of real numbers, okay, where x should never be equals to plus or minus 3, okay? So this is your domain. So all the real numbers are valid when you put them into this equation, apart from positive 3 and minus 2, okay? So this is our domain. Then how do we find our range, okay? So there is that method for first finding the inverse of these. Then again, you find that domain, let that domain be the range, but I think that is confusing and it takes your time, okay? It really takes your time. So what would be your range here, okay? What will be your range, okay? So what you can do here in a simple way, you can just say you exclude all the values that you are going to get for y when you input these 3, okay? When you input these 3. So when you input these 3, it means the value here that you're going to get will be 0 here, on the bottom. Okay. Anyway, I think let me just solve it the usual way. Okay. So you have your y, which is f of x, is equals to 9 over x squared minus 9. Okay. So what they say, if you want to find the range of this, you first find the inverse. Okay. So you say cross multiply. You have y x squared minus 9, okay, is equals to 9. So what do you get here? You get x squared y minus 9y, then is equals to 9. Okay, so what is your next step? I come here. My next step is to factorize. Is to make the x be alone. Okay, so this x squared y is equals to 9 plus 9y. Okay, then from there, I have to divide with my y. Even there, divide with my y. So meaning my x squared is just equals to 9 plus 9y over y. Okay, then after this, I can square root that, and then I square root that. So meaning my x will be equals to a square root of 9 plus 9y. Okay, so I have my y down there. Okay, so now I can find the domain of this inverse function, and the domain of the inverse function is the range for the original function. Okay, so I hope you get that. So how do I get the domain for this? I just equate whatever I have there. Okay, so plus 9y over y, okay, should always be greater than or equals to 0. Why? Because this is under a root, eh? So you can't have the square root of negative numbers. So the answer there should always be greater or equals to 0. So meaning this is my equation here, or my inequality. Then let me solve for y. Okay, let me solve for y. Okay, so whenever you have an inequality there, okay, never cross multiply. Okay, so here you can't cross multiply like that. No. Why? Because I have an inequality. This is not an equal sign. So whenever you have an inequality, what do? You find critical points and then you plot them on the table. Okay, so what are my critical points from here? So you have 9 plus 9y is equals to 0. So what would be my y here? My y there will simply be minus 1. Then the y, the other one is just 0. Okay, then I plot them. So in order of increasing number, I have 0 there. Okay. Then here I put my equations. It's just y. Okay. Then there I put test values. Okay. So here I can put -2. Here I can put what number is between -1 and half. Okay, -half. I can put that. And here I can put whatever number is greater than 0. Okay. Then let me find this. Okay. Let me find this. Okay, so there. Okay, so I divide it like that. Okay, so this is the overall here down. Okay, so 2 minus 2, if I put it there, what number am I going to get? I'm going to get 9 plus minus 18 there. So meaning here to be negative. Minus, when I put it y is minus, then minus 1 over 2. If I put it there, it's just going to be plus there. Minus 2, if I put it where y is here, just going to be minus. Then 1, if I put it there, it will be plus. And then on the y again to be plus. Meaning my overall here, what are my overalls? We have a plus there, a minus, and I have a plus there. Okay. So remember this equation at a greater than or equal to. So meaning my interests are where I have positive signs there. Okay. So it means my range, okay, so you can see that it's quite a process, eh? Just not looking at it and guessing. Okay, so my range will be all the way from -infinity to -1. Okay, then unionizing it with 0 all the way to positive infinity there. Okay, so this will be my range. Okay, and my domain. Remember that we found x such that x is a member of real numbers, okay, where x is not equal to -3 or +3, okay. So this is our range, and then this is our domain, okay. So I don't know if you have any questions. No questions, I can proceed. Hello, guys, I can proceed. Okay, question there. Okay, I can proceed. Okay, so the next question now is sketch the graph of 9 over x squared minus 9. Okay, sketch the graph of that. So let's sketch the graph of that. Okay, so just a minute, guys. Okay, let's give me a minute. Okay, yeah, sorry for that. I'm back. So here they're saying sketch the graph of f. Okay, so how do we sketch the graph of f? We see that f is what type of function, guys? It's a rational function. Okay, it's a rational function. And how do we sketch rational functions? Okay, so rational functions, we find the vertical asymptote, we find the horizontal asymptote, then we find the x-intercepts, and then we find the y-intercepts. Okay, so that's how we sketch a rational, okay, rational function. This one here, it's in the form of a over b. Okay, so this is rational. So let's sketch this graph. So what are we going to do there? Okay, so we are saying we have f is equals to 9 over x squared minus 9. Okay, so this is a rational function. What is our first step there? Is to find the vertical asymptote. Okay, so how do we find the vertical asymptote? Okay, how do we find the vertical asymptote? Okay, so to find the vertical asymptote, we equate. Okay, so vertical asymptote, we equate whatever is under the denominator there, we equate it to 0. So, okay, we have 0 there. Then it means we have x squared is equals to 9 Okay, square root this side, and then again square root that side, means our x will be equals to plus or minus 3. Okay, so meaning we have two vertical asymptotes there, one at minus 3, and then the other one at positive 3. Okay, then after finding the vertical asymptote, we find the horizontal asymptote. Okay, so how do we find the horizontal asymptote? We divide the coefficient of x on top here, and then with the coefficient of x down here. So the coefficient of x on top here, you can see that we don't have x. So the coefficient of x on top here is just 0. Then what is the coefficient of x down here? The coefficient of x here, you can see it's 1 here. Okay, this x squared here. So we are going to say the coefficient of x on top, just 0. The coefficient of x squared down is just 1. Okay, so meaning our horizontal asymptote is just 0. Okay, meaning the x-axis, right? Okay, because when y is equals to 0, it's the x-axis. Okay, and after that we find our x, okay, intercepts, x-intercepts. Okay, so how are we going to find our x-intercepts? We just equate the equation that we're given to 0. Okay, so in short, we make y be equals to 0. So there we are there, y is equals to 9 over x squared minus 9. Okay, so we are going to equate this guy to 0. Okay, so this y here becomes 0. So meaning there we have 0. Okay, we have 0 there, and then over 1. Then cross multiply. What are we going to get? What are we going to get, guys? I want someone to answer. What are we going to get here when we cross multiply? The other side we are going to get 9, but the other side we are going to get 0. And we can see that 9 is not equal to 0. Okay, meaning this graph here does not have x-intercepts. Okay, in short, it does not touch the x-axis. Okay, so we are done with that. Then we go to y-intercepts now. Okay, y-intercept, how do we find? We replace wherever there's x, we replace with 0. So it means our y will be equals to y is equals to 9 over 0 squared minus 9. Okay, so meaning our y will be equals to just be 9 over minus 9, so minus 1. Okay, so mean here the y-intercept is 0, minus 1. Okay, so now we are going to plot whatever we have here. We're going to plot vertical asymptotes. We're going to plot the horizontal asymptote. Then we don't have intercepts for x, but we have y-intercepts there. So we're going to plot this, and then you sketch your graph. Okay, so I have bar, and then I have bar. So here I'm going to put a minus 3. Here I'm going to put a positive 3. Okay, so here you can have your minus 2, and then here you have your minus 1, like that. So on top there, you can have 1, 2, 3. Even down, you can have your minus 1, minus 2 there, then minus 3 there. Okay, then the same here, 1, 2, then you have your 3 there. Okay, so after drawing this, okay, after drawing this, then we can plot those points now. So remember we found our vertical asymptotes to be 3 and minus 3. So wherever there's 3 there, you can put a dotted line like that to show the asymptote. Even where there's minus 3, you show the asymptote. Okay, so this is a vertical asymptote. Then where did we find our horizontal asymptote to be? Okay, our horizontal asymptote was 0. Okay, so meaning just above this line here, you can plot your horizontal asymptote, even below. Okay, whatever is best for you. Okay, so I'll choose on top, indicating that my horizontal asymptote is 0 there. Okay, then let me plot this point here, 0, minus 1. Okay, so 0 is there, minus 1. Okay, 0, minus 1 there. Okay, so this point here is important to show me the pattern of the graphs that I'm going to draw. Okay, so I have an intercept in between here, meaning the curve that I'm going to draw here should pass through this. Okay, And then if I have a curve down here, it means on top here, I want to have a curve of the curves in these sides. Okay, I have the curves this side and this side. Okay, since in the middle here, I have a curve in the bottom, it means I also have a curve this side. I also have a curve this side. If I had a curve on top here like that, it means on the bottom I want to have a curve. Okay, so that's how the rational graphing rational functions is. If you have a curve in the bottom there, then you don't have a curve on top there. If I have a curve down here, I don't have a curve on top there. Okay, so unless you're drawing graphs for time, but that is not actually. So here I'm going to have my first asymptote as that. Okay, like that. Okay, make sure here it does not touch that asymptote like that. Okay, so since I have a graph in the middle there down, meaning on top here I'll have nothing, then here I'll have a graph again like that. Okay, make sure it doesn't touch the asymptotes, and then even here I'll have a graph like that. Okay, so this is just a sketch. Okay, so your graph is this one. So your graph of 9 over x squared minus 9. Okay, this graph here is this graph that we have seen drawn there. Okay, so I don't know, do we have any questions? Any questions, guys? Okay, so I'll move on to the next one. I've sketched this. Okay, so now it's about solving the inequalities. Okay, solving inequalities. Then I'll move to those cubic something. Okay, then we call it a day. Okay, so solve the inequality x squared minus 16 over x1, x minus 1, I mean, squared. Okay, so on top there, we have what do we have? We have x squared minus 16 over x minus 1, okay, squared. Okay, then what sign do we have there? We have less than 0. Okay, less than 0. Less than 0. Okay, so how do we solve this inequality? Okay, how do we solve this inequality? Okay, so before we solve it, I want to give you general rules. Okay, so if you have a there, which is less than 0, okay, and you want to solve this a can represent this whole lot of thing here on top. Okay, so if I want to solve this a, then I'll put the a in between. Okay, then I'll write less than, even here I'll write less than, then I'll put 0 there. Okay, and even there I'm going to put no, I'm not going to put 0 there. Okay. Okay, so I was saying, okay, so this equation here is already simplified. I thought it was simplified. Okay, but let me continue explaining. So if I have an equation in this form here, okay, I have an equation in this form here, okay, where here I do not have a 0, okay, I do not have a 0 there. I have a number there, let me say b, okay. So I'm going to put positive b here, and then I'm going to put minus b here, okay, meaning I'm going to solve this part alone, okay. I hope you're seeing. Then again, I'm going to solve this part alone. So the answer that I'm going to get on this part, I'll intersect it with the answer that I'm going to get with this part to get the final answer to whatever I have here on top. Okay, so that is if I have a number there that is not 0. Okay, but in this case, I can see a 0 there. So meaning I can just solve it straightforward. Okay, so how do I solve it? The first thing I said, when you have an inequality, you can never cross multiply. So we can't cross multiply here. So what do we have to do? It means we have to find the critical point, and then we have to draw a sign table or a sign graph. Okay, so how do I draw a sign graph? I'll make sure I factorize whatever I have here. Okay, So this one on top here, I can see it's the difference of 2 squared. It's just x minus 4. Okay. Then the other side is just x plus 4. Okay. So difference of 2 squared on top. Then down there, what do I have? I have x minus 1 squared, meaning I have x minus 1. And then again, x minus 1. Okay. And this should be less than 0. Okay. So we are going to draw a sign graph and focus on the part that has negatives. Okay. Because this is less than. If it was positive, we would focus on, if it was greater than, we would focus on the positive part. But since it is less than, we'll focus on the negative part. Okay. So let's find the critical points here. So the critical points, you get these individual factors here, you equate them to 0. Okay. So it would be 4 minus 4. I mean, x minus 4 is equals to 0. Okay. So the critical point, the first one is 4. Then the other one is 4 plus 4 is equals to 0. Okay. So meaning my x here will just be minus 4. Okay. Then the other one is x minus 1 is equals to 0. It means my critical point there just be x is equals to 1. So it's the same for the other one. So meaning I have 3 critical points. I have 1, I have minus 4, and I have 4. Okay. So I have 3 critical points. So after getting these critical points now, I'm going to put them on the sign graph, okay, to find out which part gives me negatives and which part gives me positive. Then I'm going to get the negative part because it's a less than here, okay? So it means minus 4 there, I have 1, and then I have 4. Okay, so those are my critical points. Let's draw a sign graph now. Okay, so let's draw very beautiful sign graph there. Okay, so there you go. That. Then here. Okay, so there you have your x plus 4. Then you have your x minus 4. Then you have your x minus 1. And then again, I have my x minus 1. Okay, so you can see that when putting on the sign graph, I'm putting all the factors that are there. Okay, all the factors that are here, you have to put them on the sign graph, 4 of them. Okay, then down here, it means I have my overall. Okay, I have my overall here. Overall. Okay, that. So now let's look for numbers that will test. So let me use red here. So let's look for numbers. Okay, so here we can use a minus 5. Here in between we can use 0. Okay, then there we can use a 2. Okay, so we're going to test these numbers here. So negative 5, if I put it there, I'm going to get a minus 1. Minus 1 is just negative. Okay, negative 5, if I put it there, I'll still get a negative. Minus 5, if I put it there, I'm still going to get a negative. Minus 5, if I put it there, I'm still going to get a negative. So I have negative, negative, negative. Okay, let's test 0 now. If I take 0, I put it there, I'll have a positive. 0, I put it there, I'll be minus. 0, I put it there. Okay, I have a minus, I have a minus. Then if I use 2 now, let me use 2. So 2, if I put it there, I'll have a plus. 2, if I put it here, I'll have a minus. Then okay, guys, I forgot one number here. You also have to put a number that side. Okay, because we have 3 factors there. Okay, so here we draw an additional box like that. What is happening? Okay, yeah, an additional box there. You know, you can pick these now. Okay, so here you can put 5, a number that is greater than 4. Okay, so if I put 2 there, it's going to be a positive. If I put 2 there, it's going to be a positive. Okay, then let me now test the 5. If I put 5 there, definitely positive. If I put 5, positive. If I put 5, positive. If I put 5, positive. Okay. So now we can find our overall. Negative multiplied by negative, positive. Positive multiplied by negative, negative. Negative by negative, positive. Okay, so here it's positive. Then here positive multiplied by negative, negative. Negative by negative, positive. Positive by negative, negative. Okay. Then here positive multiplied by negative, negative. Negative by positive, negative. Negative by positive again, negative. Okay. Then here I'm going to say positive. Okay, so this is just positive. Okay. So remember our equation here, we had this time. And this time we said we're looking for the negative part. Okay. So which one is the negative part here? You can see that between -4 and 1, we have a negative part. And again, between 1 and 4, again, we have a negative. Okay. So meaning our x values here will be equals to from -4 to 1. Okay. Okay, so I was saying the negative part there, starting from -4 and it's ending at 1 there. Okay, and then again it's starting at 1, ending at 4. Okay, like that. So this here will be our solution set. This here will be our answer. So I don't know if we have any questions. Any questions, guys? Okay, silence means no question. So we've solved this. Okay, we've solved this.
Sir, on the third column, how did you come up with a positive sign on the overall?
On this one here, which column are you talking about?
Yes, that one.
Okay, maybe I got it wrong. I'm saying positive multiplied by negative, it's negative. Okay, then that negative we multiply by positive is still negative. Negative again multiplied by positive is still negative. That's how I got this. You got a different.
All right, thank you. I made a mistake somewhere. I had 2 negatives.
No problem. Okay, so make sure you follow the science properly. Okay, so right now I want us to solve those questions that someone sent in the group for cubic functions. Then we can go it a day. Okay, so I'm looking for them. Okay. This one here. Okay, so we are going to look at this question C here. Okay, question C here, because I saw a lot of people in the group asking how to solve this one here. Okay, so this is a cubic function. Okay, it's it's a cubic function, and they want us to graph it. Okay, they want us to graph it. So how do you graph such a function? Okay, so there are steps that you have to take. Okay, there are steps that you have to take. So those steps are usually arranged in the way they ask this question. Okay, so the first one is to identify the critical points of the function. Okay, then you determine their nature. Okay, then after that, you can now sketch the graph. Okay, but you just don't sketch the graph. First, you find the x-intercepts, and then again you find the y-intercepts. Then you show the relative maxima. Okay, and then again you show the relative minima. Okay, so that's how we are going to solve this question. Okay, so the first thing is identify the critical points. Okay, how do you identify? How can you identify the critical points? Okay. Okay, so to identify the critical points, we just get whatever is in the brackets here, and then you equate it to what? To 0. Okay? Yeah, no. That's when you're finding the nature. I mean, when you want to find the critical points, you expand this. Okay, you expand this, and then you differentiate it. Okay, and once you differentiate it, you equate that derivative to 0. Okay, and then you solve for x. Those will be critical points. Okay, so that's how we are going to move. So, what's the question there? Let me move this thing here. Okay, so they're saying f of x. My screen has gone again. Hey, self-talk. Okay. Okay, they are saying f of x is equals to x plus 1 in the brackets like that. Okay, then you have x minus 2 there. So x minus 2 squared. Okay, so how do you find the critical points? Okay, because our first question here is identify the critical points. Hey, now my questions are the ones that have gone. Wow, what's happening to my PC today? Yeah. Right. Okay, it is back. Okay, so the first question here is identify the critical points. Okay, so identify the critical points there. How do you do that? I said you expand this, then you differentiate it, and then you equate that derivative to 0. Okay, so how do you expand this? You first expand what is in the brackets there. Okay, so how do I expand this? I multiply x minus 2 by x minus 2. Okay, so x multiplied by x will just give me x squared. Then x multiplied by minus 2 to be 2 minus x. Okay, then 2 minus multiplied by x, it still be 2 minus. Okay, and then 2 minus multiplied by 2 minus to just be positive 4 there. Okay, so is equals to x plus 1. Then there, what do we have? Our x squared minus 4x plus 4. Okay, so this is what I have there. Then let's continue expanding it. We multiply now by this. Okay, so it's equals to x multiplied by x squared. just x to the power 3. X multiplied by minus 4x, it's minus 4x squared. Okay. X multiplied by 4, it's plus 4x. Okay. Let's multiply by 1 now. Means we are going to get the same thing there because that is 1. 4x plus 2. Okay. So now here we put like terms together. Okay, so it will be equals to x squared there. I mean x cubed. Then this squared here and this 4x squared they combine. It means you have minus 3x squared there. Okay, then this x squared they combine. So you can see that this is positive 4x. This is minus 4x. So meaning those who cancel just be 0. Then what I'm going to remain with? I'm going to remain with the positive 4. Okay, so this is my equation when I expand whatever I had there. Okay, then I said now you have to differentiate this equation that you have. Okay, so the derivative of f is equals to, okay, so what do you do when differentiating? You multiply the power multiplied by the coefficient, then you reduce the power by 1. So it will be 3x squared minus, okay, here you have your 6x. Okay, what is the derivative of a constant number? The derivative of a constant number is always 0. So here it will be 0. Okay, so this is our derivative. Then how do we find the critical points? We equate this derivative, okay, to 0. So we equate it to 0 there. Okay, then here we can factorize 3x because it's common there. So meaning here I'll just remain with x, and then there I'll remain with 2. This will be equals to 0. Okay, so meaning my 3x there is equals to 0. Then on the other side, I have 4 minus 2 is equals to 0. Okay, so here our x just be 0. This is our first critical point. Okay, and then x on the other side to be equals to 2. Okay, and this is our second critical point. Okay, first critical point, second critical point. So that question that is saying identify the critical points, we have answered. Okay, this question done and dusted. We've answered. I hope you are following. Then now they're saying determine the nature of the critical points. Okay, so after we found our critical points here, the next thing now is to determine the nature of these critical points. So how do you determine the nature of the critical points? Okay. So this one you put them as coordinates here. Okay. So it will be 0 here, comma. What am I doing? Okay. I forgot one point there. So these are the critical values for the x coordinate. Okay, these are the critical values for the x coordinate. Then we also have to find the critical values for the y coordinate. So before we move on to the second one here, I don't know why I forgot. We have to find the y coordinates for the critical points. Okay, so I was saying if x is 0, okay, then there if x is 2. Okay, so where do we substitute these values? Substitute it from the original function. Okay, so the original function was this, was x plus 1. Then we had x minus 2 squared. Okay, so this was the original function there. So meaning we have to find the y now here. Okay, so we put 0 there, when we have 1 there. Then there if we put 0, we have minus 2 squared. Okay, so what is minus 2 squared? Simply 4 multiplied by this one first. Then here, what are we going to do? We are going to put 2 there. Okay, 2 there. So it means 2 plus 1 there. Okay, then the other side will be 2 minus 2 squared. Okay, so we are substituting into this equation, right? Don't get those. So meaning there you have 3 but there I have 0. Okay, meaning here our y is just 0. Okay, meaning this side the critical point is why am I writing x here? Okay, so here the critical point is 2, 0. Then there the critical point is 0, 4. Okay, so these are the critical points now. Okay, sorry for that. I forgot about the y's. Then after that now, that's when you can find the nature. Okay, so how do you find the nature of the critical point? So that was now number 2. So how do you find the nature of the critical points? Okay, so to determine the nature of the critical points, okay, we have to find the second derivative. Okay, we have to find the second derivative. And if we find that after finding that second derivative, we need to substitute by the critical x values. Okay, if we substitute and we find that the second derivative is less than 0, then that's the nature of that critical point. If it is greater than 0, it will be minimum. If it's equal to 0, it will be neither minimum nor maximum. Okay, so let me write that down. Okay, so to find the nature, we first have to find the second derivative. Okay, so how do we find the second derivative from our first derivative, which was it? What was our first derivative? This is our first derivative here. So 3x squared minus 6. Okay, so 3x squared minus 6. Then let's find the second derivative. So second derivative is equals to a to be 6x. Okay, derivative of a constant number is always 0. Okay, so meaning this is my second derivative. Okay, so in this second derivative, I'm going to substitute the x values of the critical points. Okay, what are the x values of a critical point? One of them is 0, and then the other one is 2. Okay, so if x is 0, then on the other side you write if x is 2. Okay, so let us substitute. So it will be second derivative of 0 is equals to 6, 0 there. So this is 0. Okay, then their second derivative of 2 there. So you put 2 there. So 2 there, and this will be a 12 there. Okay, so after that now, you follow the following condition. Okay, so if the second derivative there is less than 0, okay, then it means the nature is maximum. Okay, then if the second derivative there is greater than 0, okay, means the nature is minimum. Then if this second derivative there is equals to 0, then it is neither. Okay, it is neither maximum, it is neither minimum. Okay, so according to what we got here, so when you substituted x is equals to 0, when you substituted x is equals to 0, okay, so when you substitute 0 there, we got 0 there, and we know that did I find my equation right here? Okay, so this is our second derivative. Then our first derivative was what? Okay, this was our first derivative there. Okay. Okay, so you can see that at this point here where it is equal to 0, okay, where x is equals to 0, at this point, you can see that the second derivative is equals to 0, meaning it's neither maximum nor minimum at this point where the x is equals to 0. Okay, so this is a 0, comma 4. Okay, so at 0, 4, we can say it's neither according to what we found here. Okay, so here it's neither. That's the nature. Then at this point, this side here, you can see that it is 6 multiplied by 2, which is 12. And then the 12 is greater than 0, meaning at this point where the x is 2, okay, this point here, okay, we can see that it's a minimum. Okay, someone raised the hand there. You can ask.
Sir, on the second derivative, how did we get 6x?
Okay, where's the second derivative here? Okay, oh, that's why I'm wondering here why you didn't find a number. Here it was 6x, and I just wrote 6 here, and none of you corrected me. So I'm wondering here. Okay, so here this is the first derivative. Then the second derivative, it means it will be 6x minus 6. Okay, it will be like this. This should be the second derivative. Yeah. So thank you for that. None of you reminded me. So I was wondering here. Yeah. So the second derivative is it 6x minus 6. Okay. Now we can replace here. You can see that here we are going to find the 6, 0, 0 there. Okay. Meaning the answer there should be minus 6 here. Okay. So the answer here should be minus 6. Then the answer there, it means it's going to be positive 6. Okay. Positive 6 there is the final answer. Meaning, still this is going to be the max 12 minus 6 is going to be 12. It's going to be 6. Okay. So meaning here the point will be minimum because it's greater than 0. So this will be minimum here. Then this one here to be less than 0. Okay. Less than 0, we said it is what? Maximum there. Okay. So this point here, where are the points? So this point here, at this point, we're saying it will be the maximum. Okay. Then at this point here, we're saying it will be minimum. Okay. So the nature of this point here is that it's minimum, and the nature of that point there, it is the maximum. Okay. Thank you for that. Then now, after finding the we determine the nature there. Okay. Then now you can sketch the graph of the function, clearly indicating x coordinates, x-intercept and the y-intercept, and the relative maxima and the relative minimum. Okay, so where we find it is maximum, that's what they are referring to here. Even there where we find that it was minimum, that's what they are referring to here. Relative maxima, relative, we found that. So the only thing that is remaining now is to find the x and the y-intercept. So y is equals to, we had the x plus 1, okay? Then we had the square there, okay? So how do you find your y-intercept, okay? How do you find your y-intercept? Or how do you find your x-intercept? Guys, how do we find those? Okay, so my x-intercepts, we just simply equate whatever we have here to 0. Okay, so it will be x plus 1, x minus 2 squared is equals to 0. Okay, then from there we are going to see that we're just going to get x plus 1 is equals to 0. Then on the other side to be x minus 2 is equals to 0. Okay. The one who has raised the hand, you can ask. You can ask. iPhone X Max. That's your name.
Oh, sorry, sir. I forgot to drop my hand.
Oh, okay. Yeah, so you can see that the x-intercept there, we found that it is 2 and negative 1. Okay. Then what is our y-intercept? Okay, so how do you find your y-intercept? You put wherever there's x there, you put 2 minus 0. So to find your y, just say that this was x plus 1, so to be 0 plus 1. Then on the other side, it was x minus 2 to be 0 minus 2, then squared. Okay, so the y-intercept here will be, this will be 1. Then my PC is shutting down very soon and I don't have power. Okay, so this will be the last question. So there you have minus 2 squared there is equals to 1. Then there you have your 4. Okay, then it means that minus 2 squared there. Okay, so just equals to 4. Okay, so it means your y-intercept there to be 0, 4. And then your x-intercepts there, we have your minus 1, 0. Then the other one to be 2, 0, like that. Okay, so now we have everything that we need to plot the graph. Okay, then from the graph now, okay, from the graph, that's when we can know the interval where it is increasing and where it is decreasing. Okay, so let's plot the graph. So let's write all the necessary things that we need. Okay, so the point, you've raised your hand again, you can ask. We had 0.
Sir,
Yes, yes,
when finding our y-intercept, don't we equate the x into the y, like the x into the equation, the x we found?
Which x?
The x is equal to -1 and the x is equal to -2. Don't
This
we
one.
equate these values into the equation?
Oh, you're saying we
I'm a bit
substitute
confused.
these into the equation?
Yes.
No, we don't do that. We just simply say x is 0, okay? So your y-intercept is where the graph is crossing the y, okay? So whenever that point where the y, that point where the graph is crossing the y, the x is always 0, okay? So the x is always 0. So just put, wherever there's x, we put 0, 0, 0 to find the y-intercept. We don't substitute this into the y, no. You've gotten that?
Okay. Yes.
The x is always 0, okay? So this was my critical point there, 0, 4. Then the other one was, what was the other one? I forgot there. 2, 0, okay? So 2, 0, okay? Then we said this was the maximum, okay? Then this was the minimum, okay? Then after that, what else do we need? We need our x-intercept, okay? So our x-intercept, what did we get here? We got -1, 0. So -1, 0. And, okay, what did we get on the other side? We got 2, 0. Okay, so this is a turning point and it's also a x-intercept. Then y-intercept, what did we get? Y-intercept, what did we get? We got 0, 4 there. Okay, so on the y-intercept, the x should always be 0, like that. Okay, so these are details that we've gotten from whatever we are solving there. So from now there, we can use this information to solve or to graph this function. Okay, so that's the information there. So we are going to plot now a graph. Okay, so you say this is my y, and then that is my x. Okay, so you can say 1, 2, 3 there, and then again 1 minus -2 there, -3. I say again here 1, 2, 3. You can put your 4 there, 5, 6. Okay, this graph is increasing like that, and that is my y. And again, that is my y. You can put your -1, -2, -3. Okay, so let's plot these graphs now. Okay, so x-intercept, we have 1 there. Okay, use a different color here. Okay, we have -1, 0 as my x-intercept. I also have 2, 0 there. Okay, let me plot these critical points, okay, or the turning points for 0, 4 there. Okay, so I can see 0, 4. Okay, so I put there 0, 4. Then what is the other turning point? The other turning point is 2, 0. Okay, I've already shaded it here. Okay, so this is an intercept and against a turning point. Okay, then what else? Y-intercept. Y-intercept is the same as that again. Okay, so I've already plotted this. Okay, so having plotted that now, we know that this here is just the x-intercept. Okay, then the turning point, we have this guy here and that guy. Okay, so meaning my graph should start from the bottom here and then it should go like that. Then when it reaches here, since this one is the turning point, it has to turn. Okay, it will turn and start moving down. Okay, then when it touches there again, since this is the turning point, it will start going up like that. Okay, so this is our graph here. Okay, then once you draw your graph here, you can now simply identify the region where it is increasing and the region where it is decreasing. Okay, so when it is going up like that here, this side here it is increasing. On this point here it is decreasing. On that point here it is increasing. Okay, so when they ask you to write the range on where the graph is increasing or where it is decreasing, so decreasing, you can see that it's all the way from -infinity all the way up to this point here. And what is that point there? You can see that it's 0, right? We are going in the x here. In fact, this is a domain, not the range. Okay, so all the way from -infinity here, the graph can just be going like that. It will end at 0 there, okay, increasing. And where else is it increasing? So you say union. Where else is it increasing? Starting from 2 there, okay, all the way up to +infinity there. Okay, so in this okay, in this domain there, the graph is increasing. Then where is it decreasing? Decreasing, you can see that it's just starting from 0 there, because here there's a 0, 0 all the way up to 2. That's where it is decreasing. So 0, 2, at this point here, the graph is decreasing. Okay, decreasing. So any questions, guys? Any questions? Any questions before I end my class? My battery is 7% on the PC and there's no power here. So any questions before I end the class? Okay, no question. Okay, so thank you very much for attending. We'll keep on having these classes until the day you write according to that schedule that I shared in the book. Okay, so that for those who did not attend, I'll upload this class when power comes back. Have a good day.